Okay, let's get started. This is Foghorn as usual for our standard Saturday Night Academics. Welcome to the Aurora Republic for any newcomers. Welcome to our Saturday Night Academic session, just like I already said. For our Aurora Republic members, this will be installation number 3 of our Comm Discipline and some other flying elements to talk about tonight. But before we get started on that, I'm going to first go over some announcements for the whole group. Specifically, we got a website migration and some improvements that are going on to the website, so keep an eye open for those at aurorarepublic.space. We will be making some huge improvements to that as we get them completed, and we'll keep you guys in the loop on that. The next leadership meeting will be on the 17th of March, so we need everybody who's in a leadership position to make sure that they carve that time out. That will be at 1500 Pacific time, so mark your calendars. Make sure you got the time change correct for your own personal time zone. Daylight savings time, according to my Google Calendar over here, says it's on the 11th of March, so that will be in daylight savings time. So Pacific Daylight Time, 1500 on 17th Saturday, 2 weeks from today. Immediately after, we're going to try to keep that leadership meeting to 1 hour. We have some big information to go over for the whole group, so we need max attendance for people in leadership positions. And then immediately afterwards, at 1600 Pacific Daylight, we want to have a full org meeting in the same place up in the Discord. So if you know anybody who is an Aurora Republic member but not super active and may miss it if they're not the type that checks their email regularly, there will be email notifications going out here later tonight for the full organization meeting at 1600 Pacific Daylight Time on the 17th of March. We need everybody there. We need max participation, so make sure you get the chatter up, get word out to everybody, so that we can get the maximum number of people there from our roles. Okay. The biggest thing we're going to be going over is the 2018 way ahead for the organization. We've got some big plans. It's going to take a lot of effort from a lot of people, maximum participation sort of thing. So please make sure everybody is there. Let's hit all of the communication pathways. We will send out an email alert as well, but if you know somebody who's not super active in the org right now and you have contact with them, please make sure you pass on that information. Again, so welcome. It's Foghorn. Rules of engagement for this evening, of course. This is being transmitted over our Twitch channel. So there is, of course, an 8-second delay from when I say something before it comes out over Twitch. I am monitoring on my alternate monitor here. So if you post a question in the chat, it might be a few seconds before I get there. Guahir just asked, did I say 1400 Pacific? The leadership meeting is at 1500. The full org meeting is at 1600. If you do post a question in the Twitch chat, of course, as soon as I see it, I will stop and repeat the question and then answer it so that everybody can hear and or see what was queried. Okay, so this should be fairly quick, so we can get to some flying tonight. Flight school, we're going to go over the standard HUD elements. I did this once already when I talked a bit about instrument flying, so we'll go over it again. And then, of course, Block 3 of Comm Discipline, which should be fairly short. We're going over systems and status, how you communicate that. Okay, so the heads-up display, the standard HUD elements. Hey, there's my wonderful poor man's drawing skills again. Let me get my laser. I got a laser. It's a laser. Okay, so here's my little laser pointer, as you can see, making loops around the screen here. Standard HUD elements in spaceflight, they are a little bit different when they get down into atmospheric. But you will typically have what we call a gun cross. This is a bore sight cross. It has some extended leader lines going out from it. This is basically the nose of the ship. That is where that is pointed at all times. Now, whether or not you will see this inner cross depends on whether or not you have gimbals locked or not. If your gimbals are locked, then this circular gimbal pipper will actually be welded to the center here, and it will occlude this, so you won't see that cross. This circular with the dot will be centered right there in the middle. If you have gimbals unlocked, then whenever your gimbal pipper is in front of that gun cross, the gun cross will be occluded, but every time you move it away with your mouse, this is typical of a mouse and keyboard pilot, every time you move your away with your mouse, then that will again show up. Now, the reason why you have two aiming reticles is because you could have some weapons on the ship that are gimbaled and some that are not. You could actually have a mix. The Mustang is actually typical of this. It has a chin turret that is, you can have two size 1 gimbaled weapons on, and it has mounts on the wings that you could fix a size 1 ungimbaled weapons. The ungimbaled weapons, the fixed weapons, will be bore-sighted to the gun cross, and the gimbaled weapons, if you have gimbals unlocked, will follow the pipper. So you could actually have two different aiming reticles for those two different weapons. This is where the ship is pointed. This is where you have your mouse if you have gimbals unlocked, so this is where your gimbaled weapons are pointed, and as you move your mouse around, that's where that will move to. Based on that and how you have your thrust set with your power, then that will move this velocity vector, and that's what this rounded square with a V that's either going up or down. This will actually move around on the screen and is showing you exactly where the velocity vector of the ship is, particularly if the ship is uncoupled. This is actually probably erroneous right here, because with this situation, with your nose pointed that way, the velocity vector going up and left, and you're meanwhile with your mouse you're moving your gimbaled cursor down and right. This would actually probably have an X through it, meaning you're uncoupled, so that you could be flying that way while you're turning the airplane that way, turning the spacecraft that way. The V part of it points up if the vector is generally forward, and it reverses and points down. The V part points down if it's backward. And this will go all the way off the screen if you have enough of a divergence between where your nose is pointed and where your velocity vector is going. Over on the left side with the scales, the inner scale down below is your throttle setting. So if you actually are, if you're a HOTAS person, kind of guy, and you have a joystick and an actual physical throttle, then as you push your throttle up and down, then you will see this 90 with the little caret slide up and down, 0 at the bottom, 100% at the top, and that's just basically a percentage of whatever the throttle is for that spacecraft. Same thing if you use the W and the S key on the keyboard. We'll also move that forward and back. Above it is a scale that starts at 100% and runs down to 0, and this is the hydrogen fuel that you have on board the spacecraft. It will, as you use afterburner, you can use this up as you boost in maneuvering thrust. You can use that up. In the lore, in space, you have scoops that are recouping interstellar hydrogen as you're flying around in it. On top of that, right now in 3.0 and earlier, just normal engine power just works off of FM. So, however, in the future, I believe that that is probably going to change, because otherwise there wouldn't be any reason to have the entire refueling mechanic. So I imagine that the FM engines are going to suddenly actually become fuel-burning engines in probably the near future, probably about the same time the refueling mechanic comes out. Otherwise, there wouldn't be any need for refueling. I mean, just think about it. We never run out of it now, no matter how hard you're and constantly you're maneuvering. The velocity scales on the outside, it actually has a ladder that will roll up and down. However, the actual speed number measured in meters per second is over there on the left. So this is my rough approximation of a Cutlass Black. Yeah, there'd actually be two big canopy rails going up here too. But I just edited them out so that just to kind of keep the picture clear so we could talk about it. So yeah, 220 is the max mil power speed of a Cuddy. Down on the left, down below these scales, you will see a square with 3 letters in it, SCM or PRE, and I think there's also HOV for the 3 speeder bikes. SCM is standard cruise mode, or space cruise mode, or space combat mode, depending on who you're talking to. I call it standard cruise mode because that makes sense. That gives you full range of your engines, power, maneuverability, all of that sort of stuff. When you put your gear down, it kicks into PRE for precision mode. You are now limited in speed to 50. And you will notice that the gains in your maneuvering thrusters are dialed back so that you can be more precise, but you can't be quite as do as big of a sort of Hayaka maneuver. Down below it is you'll see MS for meters per second to kind of remind you that your speed is in meters per second. You know, because it's being made by a Brit who apparently, you know, likes the metric system instead of the good old British imperial system. Who knows? I don't know why they don't have any pride left, but anyway. And then below that is a thrust setting, which is you typically will be flipping around with a whole bunch of numbers that mean absolutely nothing to us at this point. Theoretically, that's probably some sort of a trying to tell us how much thrust our systems are putting out, but right now it's virtually meaningless. I haven't found anybody who could give me a good description of what those numbers mean, what units they're even in. So there you go. Okay, moving over to the right side, you have your 2 countermeasures, chaff and flare. You know, one with some sort of a lightning bolt, and the other one with some sort of a. I put a little sun symbol there, but it's really looks like a flame. And the number that you have there that you have remaining is listed up there. Down in the lower right corner is all of your IFCS modes, whether you're coupled or decoupled, whether your G-Safe is on, whether command stability is on, and whether your ESP is on, which is for stick precision. Basically an aiming assistance. Down below that is QF, which is your quantum fuel. It'll be a big, large... actually, previously it was a big, large number. Now they all seem to be like a 3-digit number, like 538. Again, no real knowledge of what those units are, and we really haven't, you know, hardly used any quantum fuel to be able to quantum travel around the system. But running out of quantum fuel really hasn't been a player yet. If you've used your mobiGlas and you've chosen a quantum target, of course you will have a diamond and you'll have a range to that target, and of course up in the corners of your HUD, of your visor, not the HUD, on the 2 windows that are up in the upper left and right corner of sort of your field of vision when you're flying, believe it or not, are not actually part of your HUD. Those are on the inside of your helmet, where this is the static HUD that's in the spacecraft. So that's why I don't have them shown here. But if you do, you know, put your crosshairs on the target and sort of lock that as a sensor point of interest, because that's where you're going to flying to, then you'll get a repeat of that range information in the upper right. Things change a little bit when you go down to atmospheric flight. Most notably, the presence of the pitch ladders, if they show up. I'm about 50-50 about whether or not the pitch ladders show up when I descend into atmospheric flight, or I should say when I descend down into flight around one of the moons. Because I know only one of the moons actually has an atmosphere, but basically when we come out from space flight to flying around a moon flight, flying over land flight, in theory you're supposed to have the pitch ladders show up. I can usually make it down to the ground and land without them ever even showing up, and then when I take off, that's when they finally show up, and then they won't go away when I'm out flying in space again. So bugs galore. Above, the pitch ladders are incremented in 5 degrees. If you put your gun cross on one of those pitch ladders, then you are that many degrees nose high or nose low. That is the pitch of the spacecraft. That is not necessarily where the velocity vector is. That rounded rectangle, or that rounded square with the V, goes away, and it's replaced with this Westinghouse symbol, which is this sort of flying W looking thing. And that is actually where your velocity vector is. So you could be pitched at 0 degrees, but if the ship is actually flying a 5-degree descent, then of course your Westinghouse symbol will be at 5 below, and your gun cross will be up on 0. In atmospheric aviation, that's called angle of attack. That difference. assuming there's a zero angle of incidence of the wing on the longitudinal axis of the aircraft, for those of you who have a degree in aeronautical engineering and want to call me out for not being a purist. Okay, the other new additions is that you will have a max safe speed will show up. That is based if you're in an atmosphere, of course. This will always show up, but it's usually a ridiculously high number if you're flying around one of the moons that doesn't have an atmosphere, like Yella. But if you're flying around, was it Daymar? That has the atmosphere, then you'll actually see this number, and you will actually be limited by your IFCS on what your actual max speed is based on the thickness of the atmosphere of where you're at. It'll also have an altitude given out in meters. Again, I've seen a lot of error in here. Like by the time you get down to the ground to land, you're at minus 400 meters of altitude, so it's not perfect. I would not be doing a descent based on that altimeter. If you're doing something where you don't have your eyes to be able to see the ground and use your eyeballs to fly you down to the ground safely, then I would go reference my previous academics on how to do a dark side landing, so that you come in at a proper angle to make sure that you're probably clear of any sort of terrain, and then use the range to a known point, a known destination. Similarly, where I have 76 kilometers to the square with a dot is going to be a ground-based destination. So hey, Deacons, something like that. Other than that, everything else pretty much remains the same. Alright, so that's it for HUD elements for those folks of that, and we'll try to get faster and funnier. So we've got 3 more slides and then we're done. So we're going to talk about the brevity codes now for how to communicate systems and status to the rest of your flight mates, and any sort of a command and control agency to let them know what's going on with your spacecraft. Okay? Again, these would be in alphabetical order, and we'll just haul butt through them. Alarm. If we're going to do some sort of emission control, MCON, some people think that's stealth. It's kind of like stealth. You're just doing exactly what the word says, emissions control. The word for that is snooze. The word to terminate those is alarm. So the flight lead comes up and says alarm on the radio, then that means come back up and turn your sensors back on. Anything that emits, come out of a stealth mode. There's actually a different word for actual use of specifically stealth type operations. Something is bent. If you have a system that is inoperative, then the word for that is bent. So you'd say, if your radar is out, the word for radar is gadget. So you'd tell them, hey, gadget bent. Then the rest of the flight knows that your sensors are out and you're basically sensor blind. And that might have other ramifications, like any sort of weapon, like a missile that requires a radar or a sensor to be able to cue it. Then of course those weapons would also be useless if your sensors have been shot out from you, if your gadget's bent. There's also a couple other words that are related to that, and we'll get to those as we get there. Cloak and decloak. This is actually the specific. We are going to use stealth procedures. So we have the Eclipse, which is coming out here in the future, as a stealth bomber that's specifically made for stealth. There's the Hornet Ghost. I think there's another one out there that I can't remember off the top of my head, that's specifically supposed to be a stealth type ship. Cloak is at the point where you would switch to specifically covert operations, of which MCON is one of those things. So stealth, MCON, lighting, turning all the lights off, and of course the reverse of that is decloak. So there would be a spot in a mission where you're like, hey, this is our cloak line, this is our decloak line. So here's where we're going to go MCON. We're going to start using stealth procedures and equipment, and we're going to start, basically we're going to go lights out and try to become a dark black hole in space. And then of course decloak is where you come back out of that. That could be directed by the flight lead, or this is the way you'd refer to it if it was planned into the mission. Fence in and fence out. Now where fence came from was it was actually an acronym to remember all the different switch settings that you needed to do when you were entering the combat area and exiting the combat area. I actually probably should have graded this. I'm actually intended to grade this in and out because as it sits now, you're flying around with your weapons hot 24/7, except for when you go into specifically an armistice area. In real combat vehicles, because it's not just fighter jets that do this, but there will be armament safety switches. So when you'll be driving around with all of your weapon systems basically in a safe mode, so you don't have any accidents. And then once you get to the you get to the edge of Indian country, as it were, to use a cowboy colloquialism, you get to the edge of Indian country, then you fence in, and you do a fence check, which reminds you to, master arm switches to arm, put the radar modes into their war reserve modes so that they become much harder to jam. Your radios, you're going to go onto your anti-jam and secure modes. You're going to turn out all of your exterior lighting, all that sort of stuff. So that's where that came from originally. I don't know if this is going to have any place in Star Citizen in the future. So that's what fence in, fence out. Flightly would call that when you're at the point to fence in, to remind everybody, hey, go through all of these pre-combat switch settings. And then of course the reverse of that when you're coming out of the sort of combat area and you're coming home. So you safe everything up. Or when you're going to the tanker, you fence out so that you safe all of the weapon systems and everything up, because guys who are flying around with 400,000 pounds of jet fuel don't like missiles and guns flying in very close formation right pointed at them while they're passing you gas. That would, with those weapons being hot, of course. So that's what a fence in and fence out. Gadget, modern day, that means a radar specifically, and Star Citizen sensors, the sensor system. So if it's the sensors that are broken, that's been shot out of your jet, then okay, your gadget bent. If they're half working but half not, okay, that gadget's sick. And then if somehow you, like an arena commander, you manage to fly over and grab one of those wrenches and everything gets fixed, okay, now your gadget well. Jammer is ECM equipment, so gadget for sensors, jammer for ECM equipment. Light bulb is a command or a reminder to your buddy to hey, turn on all exterior lighting. The opposite is unplug. So hey, we come into a spot, we fence in to the combat area, and now after 30 seconds or 45 seconds, when everybody should have done be complete with the entire fence check, you look over and you see number 4. You look out your cockpit window, you see number 4 out there, and his anti-collisions and navigation lights are still blinking away out on his Hornet over there. Key up on your aux frequency and go, hey 4, unplug. The guy, oh crap, and turns his exterior lighting on. Same thing as you come out of the combat area, coming in, you're like, hey, we really should be blinking so people can see the nav lights and the anti-collision beacons and stuff. He's like, hey, light bulb. Parrot. Parrot is the name for the IFFs or transponder equipment that's in the aircraft. So again, it could be the parrot that's sick. If somebody's interrogating you and they're interrogating your IFF and they're getting neutral IFF from you, they may tell you, hey, check parrot. And you come back and check your IFF system and come back, and if it looks like your IFF system isn't working correctly, then you'd come back with parrot sick to let them know that it's only partially operative. All right, last one. Is it? Nope, there's one more. All right, sorry, second to last one. Snooze, that's the opposite of alarm. Initiate your MCOM procedures. Sour is whenever there's an invalid or improper response to check of a system. So if the guy interrogates your IFF, gets a bad reply from it, he would tell you, but maybe he's looking at you, he knows he's friendly, he would go, hey, Eagle 3, parrot sour. That would cue you in like, hey, why is my parrot sour? Why is my IFF giving off bad ident information? Then I would go in and start checking it, and I'd come back and maybe figure it out that, hey, the sucker's sick, or maybe it's full-on bent. Maybe I don't want to go into Indian country with my IFF squawking bad, or not working at all. So sour is the opposite of sweet. So maybe I do some work in the cockpit, and or or inside the spacecraft. I think maybe I've got it fixed. I come back and ask for somebody to check my parrot, and they turn around and go, "Yep, parrot's sweet." They turn around and interrogate your IFF, and it comes back and gives the proper reply. Then you take parrot sweet. Strangle, strangle X, strangle something. Turn off the equipment that I just told you to. So strangle parrot. If the game plan includes us going IFF off, we cross into, or we fence into the Indian country, as I say, and my 4-ship is the 4-ship behind yours, and as my sensors, as my gadget sweeps over your spacecraft, one of your guys are still squawking. I may turn around and go, "Hey, Eagle 3, strangle parrot." Remind you that you need to turn that off. I already told you what sweet. Sweet's the opposite of sour. It means that the system is indicating well. Well being the opposite of bent and related to sick. Last thing is toggle. On this slide, toggle X is the same sort of thing. Toggle parrot to execute a preview change of the avionics setting. So if we get to a spot, and this is the spot in the plan where we all are going to strangle the parrot, we're going to strangle our parrot, then as a flight layout, I would say everybody toggle parrot. Eagle flight, toggle parrot. 2, 3, 4. Okay, uniform and Victor also should be grayed out. Uniform is basically the term for a UHF radio, and Victor is the term for a VHF radio. All of my previous comments about 2-channel, 2-radio communications, and whether or not that's going to come and be useful in Spectrum, or we're going to figure out a way in something like Discord to be able to do that, these should be grayed out all based on all of those comments. So I don't need to rehash those again. Unplug, I talked about earlier. Unplug's the opposite of light bulb. It means turn off all your external lighting. Well is the opposite of bent and a cousin to sick for a system. So gadget well, hey, my sensors are now working. A wounded or wounded bird is a friendly who is damaged. So Eagle flight, mad dog. What luck? Eagle flight, off target, successful, 1 wounded. Mad dog copies wounded bird. And then Mad dog would start probably scrambling some sort of assistance for that. Yardstick should also be grayed out. Yardstick specifically in modern aviation is air-to-air TACAN region. TACAN is a tactical air navigation system. This is pretty much military specific. In the civilian world, TACAN works basically the same way as a VOR DME, VHF Omni Range, and DME distance measuring equipment. However, TACAN does it way up in the UHF frequencies, whereas the VOR DME does it down in the VHF frequency ranges. With TACAN, there's a way to do air-to-air TACAN where it doesn't give bearing information, but it just simply gives range information, DME, between aircraft that have certain coordinating channels. Yardstick probably isn't going to be, or actually yardstick as a term will probably be useful in Star Citizen just because our sensor systems already just give you range between whatever target, but yardstick is typically between friendlies. So, I just may ask for yardstick. Like, hey, how far away from you? How far away from me are you? So Eagle 1, this is Viper 1, yardstick. Eagle 1 would apply, whatever. 68,000 kilometers. Whatever that would be. Okay. I hope I didn't blabber on too long. Thank you very much for your time. We had all of one question. That was awesome. We had a pre-game question on who picks the house music, and the answer is I just off of my music library. So if you guys have, if you're not feeling it, let me know. I'm willing to mix up the tunes a little bit. I did come flying in from being out on the road for business at 2 a.m. this morning, so this is all fairly quick to get this happening. The pregame music times judge. Pregame music. I turned it off when I started yakking. So, anywho, thank you much for your time. As always, I'm always available to answer any questions. You can get me via email. You can get me via Discord. You can call me whatever you like. Just don't call me late for dinner. And we will talk to you next time. Have a pleasant rest of your morning, noon, or evening. And for the folks who are going to hang around and fly, I will be up and ready to go probably in about 5 minutes. So we shall see you then. Have a good evening. Thanks.